All right, I am back. I had to edit that last video because the lesson just did not turn out how I had imagined it when I created this Jamboard. I'm not sure why I approached it that way, but that's okay. We trimmed it up and let's do it the way that I had planned in my mind. So the next question says, an audio engineer divides 9 feet of cable into 2 equal sections to connect a pair of speakers. How long is each section of the cable? So first thing I need to do is go through this problem and ask myself first, what is it asking me to do? So I know that it has not a lot of information in between 0 and 9 feet, but I do know that I'm going to be breaking this 9-foot cable into 2 sections. Not just 2 sections, but 2 equal sections. The next, I'm going to read through again and pull out all of the quantities. In this case, it is 2 integers, so 2 whole numbers. It says an audio engineer divides, that's going to be really important in just a second, 9 feet of cable into 2 equal groups. So that those are my quantities in this problem. 2 equal sections to connect a pair of speakers. How long is each section of cable? So now my third read through, I'm going to go through and decide what I'm going to do with my quantities and my keywords that I've pulled out and address what it's asking. So an audio engineer divides 9 feet of cable into 2 equal groups. Most of the time you won't have this here for you to fill in, but you could easily draw or make a mental picture of what's happening here. I can envision that it's going to be about right here, but now I'm going to use what I know how to model this to get an exact answer. Okay, so I'm going to use the tools over here on this side. I'm going to do a rectangular model again. So I'm going to make my first rectangle here. Then I'm going to use this feature, this duplicate feature, to duplicate it several times. So I need one model to represent each foot of 9 feet. So the first model is 0 to 1 foot. The next one is 1 to 2 feet and 3 to 4 feet. I'm sorry, 2 to 3 feet. Okay. So I'm going to go ahead and get all 9 feet together here. Didn't really have a way to do this ahead of time. I apologize. Okay, so we have 6, 7, 8, and 9. So to determine what this would look like, or what our quotient is going to be here to determine the entire 9 feet, I'm going to decide that by using a model that shows each foot. So this first foot, I am going to divide into 2 equal sections for foot 1. So then for foot 2, because we're trying to get equal sections for the entire 9 feet, I'm going to do the same thing. Break the next foot into 2 equal sections. And then the third foot into 2 equal sections. And the fourth foot, and so on, until I have divided each section into 2 equal sections. So each foot into 2 equal sections. So if I looked at these models, I know that 2 1/2 foot sections, I almost skipped that part, 2 1/2 foot sections now make up what was before one whole section, or something that represented one whole section. So based on what I know about fractions, I know that if I look at each one of these, 2 of the halves make one whole. So another 2 halves make one whole. Here I don't have another half to go with that one, so I'm just going to leave that one for just a minute. So over here, another 2 halves make one whole, and these 2 halves make one whole. So this is kind of like looking at this first section here. Now so I have 1 whole, 2 holes, 3 holes, 4 holes, so 4 whole. But now I still have this last model here, or this last fraction, one whole foot left. So I know that this is 1/2 foot and this is 1/2 foot. So you see, so we're going to put our 1/2 foot here. And I still don't love the way I showed you this online, so I'm going to color it in just so everybody can see this model, that if I broke each strip into half, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9 halves. 9, and we represent halves, or 9 out of 2. 9 halves is 9/2. So looking at this as fractions are division, we can say 9 divided by 2 to check our thinking. 9 divided by 2. We can make 4 groups of 2. The value 4 groups of 2 is 8, with 1 piece left over. But of course, we don't use remainders when we're working with fractions. Instead, the number that remains is the piece that's left over out of the pieces that make a whole. So when we checked our thinking using an algorithm, or standard division here, we ended up with 4 1/2, which was equivalent to 9 halves, which is equivalent to our model when we counted this up. Hopefully that was a better explanation. Still not perfect, but I will go through and model some more for the upcoming week.